Okay, this is lesson 9.5, which is determining the number of x-intercepts, also known as roots, for the graph of the quadratic using the discriminant. So before we get started, remember the discriminant from last unit is b squared minus 4ac. Okay, and one more quick note about that. Let me find. When we're talking about the discriminant, remember the discriminant's part of the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this part right here, this is the discriminant. And if you remember, this tells us how many solutions there will be. So let's look at 3 quick examples before we start on the lesson. If you had x equals 6 plus or minus the square root of 36 divided by 2, this is going to give you 2 solutions because it'd be 6 plus or minus square root of 36 is 6. So this would be 6 plus 6 divided by 2 and 6 minus 6 divided by 2. 2 solutions. The discriminant here was positive. Now let's look at when the discriminant is, say, 0. X equals 6 plus or minus the square root of 0 divided by 2. Well, the square root of 0 is 0. Oops. So this would be 6 plus 0 divided by 2 and 6 minus 0 divided by 2, which gives you the same exact answer. So there's only one solution. Again, this is when the discriminant was 0. Lastly, if you have x equals 6 plus or minus the square root of negative 36 divided by 2, well, you can't take the square root of a negative number. You just can't do it. So this whole thing doesn't exist. There are no real solutions. And this is when the discriminant was negative. So we're going to build on this idea for today's lesson. So how many solutions does the quadratic below have? This is from last unit, but in order to do this, we had to have this set equal to 0. So first we're going to subtract 7 from both sides. 0 equals x squared minus 6x minus 16. Now that we have that, if we're being asked how many solutions, we need to know if there are 0, 1, or 2. So we're going to use the discriminant. So we'll define a, b, and c. Remember, this is ax squared plus bx plus c. So a is 1, b is negative 6, c is negative 16. And we're going to substitute that into b squared minus 4ac, because that's the discriminant. So negative 6 squared minus 4 times 1 times negative 16. 36 minus 4 times negative 16. 36 plus, this is 64, which is 100. This discriminant is actually positive, and therefore there are going to be 2 solutions. Again, because it would look something like that, yielding us 2 solutions. Now, the question here is, what are the roots to the quadratic below? Remember, roots happen when there are x-intercepts, and they happen when y equals 0. So first thing we're going to do is we're going to substitute 0 in for y. Now, if you'll notice, this problem is exactly the same as this one. These are the same thing. So if you're going to solve for the roots using the quadratic formula, x equals a negative b plus or minus the square root of b squared minus 4ac, which is 100, to a, you're going to get 2 solutions, which in this case are actually our roots. You're going to get 2 roots. So if the quadratic has 2 roots, the graph's going to look like this. Let's move on to example 2. How many solutions does the quadratic below have? So we're going to use the discriminant. It's set equal to 0. A equals 1, B equals -6, C equals 9. So b squared minus 4ac, b squared minus 4ac. Okay. 36 minus 4 times 9. So 36 minus 36, which is 0. The discriminant is 0. Therefore, how many solutions are there when the discriminant is 0? There's going to be 1 solution. Okay, we're going to use, what are the roots? Roots are x-intercepts, which happen when y equals 0. So I'm going to substitute 0 in for y. Again, we're solving for roots. And if you notice, this is the same equation as this. So we've already solved for the discriminant. So x equals a negative b plus or minus the square root of the discriminant all over 2a. So our roots here, 6 plus 0 divided by 2 and 6 minus 0 divided by 2. Our root is 3, 0. So there's only 1 root, 1 solution, 1 root. So if the quadratic has 1 root, it's going to look like this. Or it might look like this. Either way, it's only going to touch the x-axis once. Last one, then we'll kind of summarize it. How many solutions does the quadratic below have? Again, the first thing we need to do, set it equal to 0. We're going to do the discriminant because that tells us how many solutions there are. A equals 1, B is -6, C is 10. B squared minus 4AC. 36 minus 4 times 10. 36 minus 40, which is a -4. So here the discriminant is negative, which means there are going to be 0 solutions. What are the roots? In order to solve for roots, we substitute 0 in for y. And for the third time, recognize that this is the same equation as that. So we've already done the discriminant. X equals a negative b plus or minus the square root of the discriminant divided by 2a. We can't do this. So there are going to be no roots. No solutions, no roots. If the quadratic has 0 roots, that means it touches the x-axis 0 times. So it'll look something like this, where it's off floating. Notice that this doesn't touch the x-axis. Or it might look like this. Okay? So that was kind of like an investigation. It was a warm-up. But ultimately, our goal is to be able to use the discriminant to determine how many roots are going to be, as well as work backwards. So here, there is 1 root, which means that there is 1 x-intercept, there is 1 solution when y is 0. So the discriminant had to be 0 in order for us to have 1 solution or 1 root, because the graph touches the x-axis once. Moving on, this one has 2 roots, which means it has 2 x-intercepts. It has 2 solutions, or what we call zeros. So if we had 2 solutions when y equals 0, then the discriminant would be positive because it touches the x-axis twice. Here you can see that this touches the x-axis 0 times. And if it touches the x-axis 0 times, then the discriminant must be negative. So quick conclusion, if the discriminant b squared minus 4ac is positive, then the quadratic has 2 real roots. If the discriminant is 0, then the quadratic has 1 real root. And then lastly, if the discriminant is negative, the quadratic has 0 real roots.